Okay, hopefully this is working all right. All right, so immutable sequences. We're going to start, as last time, with a interactive session, which we have here. I haven't exited the last night's one. So we learned yesterday about tuples, which are sequences, and they are immutable, right? We're going to see the counterpart for that. Mutable means changeable sequences. And the easiest one is the list. We just replace the round brackets by square brackets. So we can say 1, 2, 3, A, B, and C. All right, so this is a list. As we pass it in from the prompt, the fact that we don't get an error means that this is a correct expression. Typically what we're going to do is name it something, right? So let's call this list L, right? And then whenever we recall the name of L, we get back the value. As it happens with tuples, we can extract individual elements of the list. So if I say L index 3, I'm going to get A. L index 0 is 1, right? As before, my negative indices count elements from the end. Len will produce the size. All right. And then as it would happen before, let's say we have another list which we call L1, and let's add some more elements. The plus operator will produce a completely new list that represents the concatenation of the previous two lists, right? So L has the same value, L1 has the same value, neither of them has changed. What is new is that we can change elements of the list. So I can say L, let's say index 1 is assigned, let's use one that we have seen before, right? So L3 is A, right? So now I can say L3 is 1.23, right? So we see that this assignment does not yield an error, which means that it's correct. And if I look at L, I see that the third element, remember we count from 0, the third element is 1.23, right? This is also what we get by evaluating L3, which previously used to yield A, return A, now returns 1.23. We can extend the list, and we can extend it one element at a time. So we can say L.extend, L.append, I think. So I can append a single element, let's say 1000. And if I look at L, now L has a new element at the end, right? And I can extend the list by another list, right? So now L also has the elements 100, 200, 300 that belong to L1. L1, on the other hand, has not changed, remains the same. It's not that we've taken elements from one and put them in a different place. Okay, questions? Can I append a double? What do you mean? A tuple. If not, changing between tuples and lists is very immediate. But let's give it a try. So let's say L plus say X or Z, Y, and X. And let's see what happens, right? So we can't. Nevertheless, in converting between sequences, this is always very easy. So I can always say list. Notice the double brackets. The outer brackets are the arguments to the function. The inner brackets represent the tuple, right? So if I do this, there's no problem, right? Converting between a list and a tuple is very easy. I can also say tuple L and then I get a tuple corresponding to L, right? So these conversions are immediate. So no need to worry. Yeah. All right. So that's pretty much all you need to know about lists, right? They can be very useful because of their mutability in the sense of using less memory, right? Saving memory. Not that you would notice in the kind of programs that you're going to be writing. So in most cases, the recommended approach is to use immutable data, right? And to create new collections, even though they're large and they take up memory, create new collections instead of modifying old ones. So between lists and sequences, tuples, you can always solve a problem with tuples when you can solve it with lists. All right. Another type of collection which is very useful is the one of the type one called set. So sets are defined by curly braces, as you know from mathematics. And I am going to repeat elements here, and let's see what happens. Right? So a set, as you know from math, contains every element a single time, right? Multiple occurrences actually don't count. And this is the case that we see here, right? All the duplicates have been removed. So this is an important thing. Now, it so happens that we got the elements in increasing order. This is coincidental. The elements inside a set are in unpredictable order, all right? The storing technique for elements inside a set is called hashing, and hashing does not look at magnitude. So it's completely oblivious. It's just coincidental that it happened this way.
So in the list, it was in chronological order, right? So did the list order then in any way?
List, whatever order you provide, that's the order, right? This order will never change. The order in which you write them is the order in which they will.
So in a set, if you put it in a certain order, it could give you an output in a different order.
If I put them in?
Like let's say you put in 1, 2, 3, 4, 5, it could give you 4, 3.
Set, yes, the set, yes. Right, so you should not rely on the order being a specific one. Yeah. So if you want orderings, either the tuple or the sequence is better, right? Now, if you have a set S, always it's very easy to say tuple of S, and you're going to get a tuple, right? And then because the order is random, you can't rely on the order, you can always say tuple S dot sorted. Or sorted tuple, sorted. Yes. Oh, and sorted will always give me a list. That's very interesting. So in which case, I probably don't need tuple here. Sorted S. All right. Right. So if you want to put them in an order of magnitude, you can just use the predefined procedure called sorted and invoke it on the data, and you're going to get a deterministic order. Yeah, and there's not a lot of cost in using sorted. Now, interestingly, a string is also a sequence, and it's an immutable sequence, like a tuple, right? So if I write a random set of letters, all right, let's call this str, right? So this is a string. Whenever I recall the name str, I'm going to get this value. And then I can say str4, and I'm going to get the fourth letter. Yes, so it's also a sequence. So consequently, it's I can't change it, right? So if I try something like this, it's not going to go through. Nevertheless, I can turn this into a tuple. I can turn this into a set. All right. So, for instance, if I want to have all the occurrences of the letters inside a string, it's very easy to just turn it into a set, right? If I would ask the question, how many distinct letters are there in a string, right? So let's say I create the string S1, and I'm just typing completely randomly here. So the question is, have I typed any quotes? All right, so this is S1. How many distinct letters do we have, right? So it's a very simple question to answer. I'm going to say len of set of S1, right? We have 49 distinct letters. So converting the string into a set, right? Set of S1 will give me all the distinct letters, right? Each letter will occur only once inside the string. And you can notice here that even though, I mean, this is a set, the letters do not appear alphabetically increasing, right? The order depends on the hashing function. Well, it's a computer science technique. I don't want to go into it, right? But the order will be random for sets. If I want these letters in alphabetical order, I can say sorted. And then there we go, they are in alphabetical order. All right. The alphabetical order is a bit strange because there's an overall character order, right, that subsumes the alphabetical order, right? And all the capital letters are smaller than all the lower caps letters, right? So then we're going to see all the caps letters first and then all the lower caps letter later. Cool, right? And the final type of collection that we need to talk about, and it's pretty fine in Python, is that of a dictionary. A dictionary is like a list, but the index can be anything. Well, not really anything. Can be anything immutable. All right, which is important to understand what is immutable and what isn't. So, how do I define a dictionary? I will define it as pairs, as a set of pairs. So I'm going to say that D is, and I'm going to open a brace, and I can write for A, I get 1, let's say, B 2, C 3. All right, so D is a dictionary, and I can now index D by, so inside this is a pair, right? And I know that we said that pairs are tuples, and tuples are written in round brackets, but not for dictionaries, right? So for this kind of pair, this is called the key, and this is called the value. And then often we refer to this more specifically as a key value pair. Not just a pair, but it's a key value pair, right? So whenever you hear the terminology key value pair, we're talking about a dictionary, or more generically, at the larger scale, we talk about maps. So dictionary at large scale, they become maps. They're called maps, or they're called key value stores. Right, when you have an entire computer turned into a storage for key value pairs, right, the entire computer becomes a dictionary, then it's a key value store. And I can index D by A to get 1, B to get 2, and so on, right? Dictionaries are mutable, meaning that I can say DB is assigned 1000, and this works. All right, and I can assign, so previously you saw that the list can be expanded, right? I can assign to completely new keys. So D here, and I will say 2000, And this works too. And now D also has this pair, has a new pair here, right? I can define as many pairs as I like. Okay? All right, so it expands that dynamically. What if I want to delete a key? Right, so once I put it there, I can always change its value, but what if I want to delete a key? So it turns out that saying none here doesn't quite work, right? We still have the key D inside pointing to this object called none. So what we need to do is use an operation called del. So I can say del D, right? And now D has lost, the dictionary D has lost the key called D. All right. As before, we can union dictionaries. So let's have two dictionaries. We have already one called D, and let's have a D1 where we add a key C. So let's have some repeated keys and some non-repeated keys. So this is 2000 and D, which is 3000. And yeah, let's add another one, F, which is 4000 as a value. So what happens if we have D1 plus D? This actually doesn't work. D1 dot can I add can I say D1 plus so if I say D1 items all right, so one thing that we can do is take a list of elements. So let's say I have a list L, which I define as a list of pairs, a list of tuples, right? Each tuple being with two elements. So let's say I have A1, B2, C3, and then I'm going to repeat some of them, right? A 1000 and C 3000. All right. So what happens if I convert this into a dict? I can say dict L. All right. So notice what happens. Each of the pairs is converted into a key value pair, right? But the older ones are clobbered, right? So it will start by adding this to the dictionary, then adding this one, then adding this one, right? Then the key A already exists. Yeah, yes, each key has to appear only once in a dictionary. It cannot appear multiple times, right? So this value of 1000 overrides the value of 1, right? Clobbers the value of 1. The same for C. So at the point when we reach to the pair C3000, there already is a key called C inside, right? So that value is going to be clobbered. So what we are left with is as we go from the left to the right, the values, the last values for the keys. All right. Yes?
Sorry, quick question. So would that, since you're assigning like them values, right? So like A, B, C, whatever, would they also work outside the like list thing, or would they not work? Are they like global variables? Could you use them anywhere?
What do you mean global
Like
variables?
If you type out A, would it, because you defined it as something, would it then be?
No, so now I would have to say D2 is dictel, right? And now I can say D2A, and I get 1000. A is not defined. Yeah, so you do know something, probably you might have read somewhere. So whenever Python is trying to be very helpful, so it has a bunch of utilities that are allowing you to inspect the current environment. One such utility is dir, right? And dir will give you a list of symbols, right? Remember sum of squares, so that we defined last time, right? So all these are defined in the current environment. This is the list of symbols, but these symbols, you're going to find out that they're actually the keys to a dictionary, and each environment is a dictionary, and you can play with that, right? At the meta level, you can do meta level programming in Python, and you can a program can modify its own environment, can treat its own environment as an object and operate on it. This is an advanced feature, and we don't want to go there, right? But this is how, for instance, you could insert a global variable into a program from, say, something like a plugin. Anyway, so let's not go too far on this. Let's try to write some code using especially sets and dictionaries. All right, so we're going to start with number of occurrences of letters inside a string, right? So I want to not just have the distinct letters, but I would like to know how many occurrences of A, how many occurrences of B, how many occurrences of C, right? In order to do that, we're going to use a dictionary. We're going to define occurrences of a string S. And we're going to introduce a bunch of new Python primitives, like the for loop. We're going to start with a dictionary D, which is the empty dictionary. So guess what? Because dictionaries are a lot more common than sets. The empty curly braces actually mean the empty dictionary. Yes? Oh. So maybe that's what I have to do. Look at it. Turn my head and then it. So the empty curly braces are the empty dictionary rather than the empty set, right? If I want the empty set, I'm going to have to say this, right? Both sets and dictionaries are indicated by curly braces, right? And the empty curly braces could mean both a set and a dictionary, right? And it turns out that Python prefers this to be the empty dictionary. Now S is a string of letters, and then we're going to iterate through all the letters in S. So I'm going to say for letter in S. So now this letter will in turn become each single letter in S. Let's say S is ABC. Let's say S is ABC, right? The string ABC. This letter variable will first become A, and we perform a computation. Then it will become B. Then it will become C. Yeah. What's the?
Like disconnecting, connecting again, because I think there's a lag, huge one.
I don't know what to do. I'm connected. It shows fully connected. But it worked fine in. No.
It worked fine until you started saying.
Until I started the editor, right? But you see, the CPU is mostly idle, so there's no good reason. Why though? So the problem only appears here, right? All right, so for letter in S, so this, if S is the string ABC, this letter will first be A, and we perform the computation, then B, and we perform the computation, then C, right? So what we're going to do is, so D is an empty dictionary, right? So the letter, this letter might already be in the dictionary or not, right? So we're going to use a feature of dictionaries that we haven't discussed yet. Let's say I have a dictionary D that is A1. We're going to talk about object-oriented programming a bit later. Let's just learn now the fact that some of the dictionary operations can be accessed by this dot and an operation name, right? So I have this operation called d.get, all right? So d.getB will return none. And you see nothing being printed, which means that the value that came back from this expression was none, N-O-N-E, right? If I retrieve a value that exists, I'm going to get that value, which is 1, right? This is different from accessing with indexing, right? Which, in the case of a key that doesn't exist, will return an error. So having an error is bad. Having a return value indicating the lack of the key is a lot better, right? Because it doesn't blow our program. So we're going to prefer to access the elements of the dictionary using this get, right? Normally, if the key exists in the dictionary, both of them do the same thing, right? So D index A is the same as D get A. But if the key does not exist, D get B doesn't blow the program, whereas D index B does blow the program. Okay, so this is how we prefer to use it, right? So we're going to have two cases. We're going to say value is d.get letter. All right, if V, so if V is different from none, all right, so none counts as false, and let's check that as well. I can say if, let's say x equals 1. So I can say if x, then print 3. Sorry, if x print 3, right? So this prints 3, whereas if x is equal to none, I do the same thing, it prints nothing, right? So we have Boolean values that are true or false, but any other value sort of maps into true or false. Everything that is not none or not false counts as true, right? Or not 0. 0 is also, if I say x equals 0, then 0 counts as false, right? If I make x equals 1, one counts as true, right? So the following are the false values: the actual false, 0, and none. Everything else is true, right? Including the word true. Normally, for being explicit, for making our program easy to understand, we want to use true and false. But we can take advantage of this peculiarity of Python, right? And we can just test directly on values that are not necessarily true or false, right? So when we perform this, evaluate this expression, V may become either the value of the key, or if the key doesn't exist in the dictionary, V becomes none, right? So if V, so what we're going to have here is the contingency where the letter does exist in the dictionary, right? So then what should we say? We should say that D letter. So now I can index because I know that it exists, right? So D letter should be assigned V plus 1, right? V is a value, right? And then it means that we have found another occurrence of the same letter when we have to increase the number of occurrences. Else, and this is the contingency where the key does not exist. So we're going to say D letter is assigned 1. We just found one such letter, right? The first occurrence of this letter. So I'm looking at this letter, which is in the string. It didn't exist in the dictionary because V returns none. So it means that I have just found the first one, and I have to set that this is the first one, right? And I am going to return D. So D is going to tell me the I'm not sure what I did here. Okay. All right, so let's do some tests, right? So print in the string. So I'm going to do ABC, 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 right? This is easy to verify. And I'm going to say here, all right, let's make this smaller. And let's break this into 2. All right, so I'm going to do this for a number of strings. And yeah, let's do X, Y, X, Z, Y, Z. All right, let's just put them in slightly different orders. And then let's go here and say something very arbitrary. And then here let's put like special characters. All right, and let's run this piece of code. So we should go into the correct folder. Right, so we see that ABC, 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 each of them appears 3 times, right? And X, Y, X, Z, Y, Z, each of them appears twice. There's less regularity. This is a completely arbitrary string. So we have a variety of occurrences here. some 3 times, some 2 times, twice, and then the same here, right? This is a string full of special characters, and each of them have some number of occurrences. We are printing out directly the dictionary, right? And the dictionary will show the number of occurrences for each of the letters. Yeah? Is this clear? Is it clear how it works? Let's explain again, right? So what do? We have a string. The string has many letters. Some of the letters may appear more than once. Yeah? We start with an empty dictionary, and we iterate through all the letters in the string, right? So letter becomes the first letter in the string, then later, and then as it becomes the first letter, we execute this. Then it becomes the second letter in the string, and then we execute the highlighted part. Then the third letter and execute the highlighted part, right? What do we do every time? Well, we try to retrieve the number, the frequency of that letter in the dictionary, right? But this may be a completely new letter. So if it's a completely new letter, V will have the value none. Otherwise, V will be a number, telling me how many previous occurrences of that letter are there. So if V is some number, all right, we can just increase that number by 1. We can just change the value of the frequency of that letter to be V plus 1. Why? Because this is just a new occurrence of that letter in the string, so I have to increase it by 1. Otherwise, it means that I'm seeing this letter for the same time, for the first time. As I'm scanning the string from left to right, I am seeing this letter for the first time. So I have to say that the number of occurrences for this letter is 1. Yeah? And we keep doing this for all the letters in the string. At the end, when we have completed this iteration, we will hit the return statement and we return the accumulated frequencies in the dictionary D. Yes? Yes?
So if V is just short for if V is true.
What do you mean V is short for true? V is a value, right? It can be either 1, 2, 3, or it can be none.
So that means that as long as V is not 0.
As long as V is not,
0.
but V will never be 0. How would it become 0?
Or if it's not done.
No, there's no it is not done. It is, we are iterating through all the letters in S. This executes for all the letters in S, right? This is not a while loop. I'm not sure why, when you're saying it's not done, you might have had some other experience with some other programming language, and you're bringing that in.
I think it's a little confusing because just now when we did if x then print 3, and then when you made x equals none, it didn't print 3. So when you say if v, is it just checking if v equals to
V,
none, and then if it doesn't equal to none,
this doesn't check anything. This doesn't check anything, right?
yeah.
This checks whether V is none or not.
Okay.
This doesn't check anything. This simply retrieves the value. Yeah? So, one thing I can do, right, if this is not, V from this point on is a synonym for this. Yes? So one thing I can do is take this and replace it V here, right? I can write my program like this. Does it make sense? But now I have this expression which is rather long, and I have to write it twice, which means that it also gets executed twice. Takes longer each time it executes, right? If I go back to this form, right, V is just an abbreviation for this expression. Yeah? And then I can use V here, and I can use V here. So this is just naming something. I take this expression and I name it V. And from this point on, instead of using the highlighted expression, I use V. I use it here and here. Why? Because it's shorter. Makes my life easier. Right, so this is a possible use of a dictionary. We're going to see this. We're going to go a little bit into data analysis later, and we're going to see a lot more sophisticated uses of dictionaries. All right. Let's do another thing. Let's take a string. And let's do something to it. Let's capitalize all the letters, which actually is let's capitalize all the vowels. All right. So not all the letters, but only all the vowels. So if I have a string made only of letters, let's say, I will check for vowels and capitalize the vowels, right? Def capitalize. And I get a string S. And what happens here is S is immutable as a string, right? So what can I change? I can change a list, right? So let me convert this to a list. I take S, I put a list around it. L is a list of letters now. Yes? And I can say for I in range, right, from 0 to len L. Okay? So instead of going through the letters, I go through the indices. Why do I go through the indices? Because I want to change the element at an index. Okay? So I'm going to say, what are the vowels? So the vowels should be a set. I'm going to have a set of A, E, I, O, and U, right? Hopefully you know this already. These are the vowels of the alphabet, of the English alphabet. Right? So we're going to say if L index I in. So there's this interesting keyword, interesting operator that checks for membership inside a set. All right. What are we going to do? We're going to say Li, and let me remember, let's say I have a string, and then I'm going to say upper. Yes. Right? So I can get the version, the uppercase version of a string by just saying dot upper. Okay, so easy peasy. So we're going to say Li is assigned Li dot upper. Yeah. And we're done. Now we have to take L and turn it back into a string. So I can say, and unfortunately, this will not be as easy, right? So if I take a list, if I say str, and I take a list of A, B, C, this will not return me the string ABC. Okay? So the correct thing to use here, right? I have a list of strings and I want them joined. Will be, let's say I want them joined by minuses. To say minus dot join, I think it's this one. I'm not completely sure. Yes. All right. So what happens here? I want to take A separator, B separator C, right? And then the separator will be the main string. I'm going to say minus dot, and I'm going to pass in the list of strings that I want to be joined, and then I'm going to produce this join. Does it make sense? So let's say I have a list coming from somewhere that is string ABC, string XYZ, and string PQR. So this is L, right? And I want to produce the string ABC equal XYZ equal PQR. I want to produce this string, right? How do I do that? Well, I'm going to say equal dot join L, and this is what I get. That makes sense, right? So what if I want to have them joined without any equal? Very easy. I'm going to just put the empty string here, and they're going to be joined by the empty string. So what do we want to do in our original problem? We have the list L of all the letters. Now inside this for statement, we have changed the vowels to uppercase. Yes. And then I want to put the letters together in one string without any characters in between, right? I just want to put them together. So I'm going to return, and it's going to be empty string dot join L. Yeah. So let's print a verification. For the string, I'm just going to go with random letters, and we're going to say capitalize vowels, and we're going to take this string and put it inside here. And this is simple enough. We don't need to have multiple verifications. I'm going to put an empty line here so that it's easy to follow. Get out of here and run our program. Okay, and you can see here this string where all the vowels are uppercased. Yeah. Yeah, fine. All right, last thing we solved, which is kind of a famous programming problem, is palindromes, right? What's a palindrome? It's a string that reads in the same way from left to right and from right to left. Yeah. And I don't have a bunch of good examples. Let me actually try to get a list of palindromes. Okay, Madam refer race car. Race car is, yeah, was the, I was trying to remember this one. Right, so race car is a palindrome. Now, there's a very easy way to check whether a word is a palindrome, right? Because we have this predefined procedure called reversed or reverse. Is it here? This is strange. Oh, dear, I have to say dear built-ins. And do we have a reverse here? Reversed here, okay? So if I have any kind of sequence, right? Let's say I have the sequence ABC, 1, 2, 3, right? If I say reversed of this, I'm gonna get a lazy sequence. So to make it into a string, into a list, I should have list reversed, right? And then it's going to be 3 to 1. So for a string, it's going to work in the reversed ABC. Does it work as a string? No. If I say str of this, what do I get? All right, so in order to produce reverse stuff, I will have to apply the same trick. I'm going to say, I have to say empty string join of this, and I'm going to get CBA, right? So the way to check whether something is a palindrome, let's say my prospective palindrome is race car, right, is going to say to check whether P is the same as dot join reversed P. Okay, so this is true, and if I have a completely different, let's say I put an X here, a non-palindrome is going to be false. Yeah, so we have a very simple way of doing it. And I could just say, is it palindrome? I have to return true or false. And I put in just this expression, and this is done. It's a very simple solution, right? But we don't want to do it that way because it's not fun, right? So let's try to build a solution that assumes that reverse didn't exist. Let's assume that the reversed procedure doesn't exist. Def is palindrome S. All right. So we're going to turn L into a list, and then we're going to go for I in range. We're going to start from 0, and we're going to stop at the length of list divided by 2. All right. So if the length of list is say 3, length of list divided by 2 is going to be 1, right? Because this is integer division. Actually, I can say that it's integer division like this. And yeah, I think we did introduce that. So 7 divided by 2 is 3.5, but 7 divided by 2 with a double slash will always return an integer, right? We'll remove the fraction. We'll remove this part. And this is useful in this case. So for in range from 0 to len, all right? So what are we going to say? If Li is the same, is different from L
Well, can you explain why you put the divide sign twice again?
Okay, so 7 divided by 2 is 3.5. When I do a double slash, I get the integer part of that.
Does it round it or does it give the integer?
It's always no, it doesn't round it. It's always by truncation. Always truncates, which is the right thing to do in this case. Integer arithmetic, that's how it works. All right, so L0 L minus 1. So we're going to say minus I minus 1. All right. So when I is 0, this is the first element, and this is the last element, right? When I is 1, this is the second element. This is the last but 1. Yes? What should I do? Okay, now it works. So for all these elements, right, we're going to go from the beginning to half, right? So this is going to be going on the left side of the string. This is going to go on the right side of the string. When I is 0, this is going to be minus 1, right? So I'm checking the 0th element with the last element, right? When I is 1, this is going to be the first element, and this is going to be the last but 1, right? So we're going and checking whether the letters are the same, right? Coming from the extremities towards the middle. And they have to be equal. If they're not equal, so I'm testing for non-equality, I can return false. On the first opportunity, on the first occasion, I find that they're not equal, I know it's not a palindrome. Yes? Otherwise, actually I don't have to do anything otherwise, right? If I have not returned false yet, and I have reached the end of the list, I can return true. Yes? So I'm looking for opportunities to return false. I'm coming from the extremities towards the middle, and I'm checking whether the letters are the same. If they are the same, I don't do anything. I keep just going towards the middle. But as soon as I found that there's a difference, I can return false. If I have made it to the end of the number range and have not found any difference, I can conclude that it's a palindrome. Yeah, so let's print and then we're going to say is palindrome race car. And let's do this a few times. What other palindromes were there? Kayak, radar. And then let's have one that is not non-palindrome. It's delayed again. All right, there you go. All right, so we have printed a number of verifications. Oops. Yeah, then I can you see? Okay, so yes, you can see L. So does not list its L. Okay, finally. So notice that this is L, okay? Right here. Right? So we're waiting for it to update. All right, there we go. Right, so I've run the program already, and you can see that race car is a palindrome, kayak is a palindrome, radar is a palindrome, and non-palindrome is not a palindrome. Yeah. This is it for tonight. Questions? Otherwise, class dismissed. If you want to stick around for questions, feel free to.